Thanks. So, and the slides that I think you can download are basically these slides. Afterwards, I put in a few exercise points. So all they really are is just exercise points. There's really no new information there. So by downloading what's out there, you're going to get the basics of this presentation. And I realize a lot of people are probably down in the AI session. We've had several AI sessions here. And we coordinate a little bit with some of us that do a lot of conferences, particularly between people like Tariq and Jason, who have become good associates with. And this session, while it's a little bit IoT focused, and I've been doing that this year with IoT embedded, because that's my, I'll say, area of interest, research, and experience. The issues of environments and architectures and viewpoints will actually be rather important, we believe, for the AI movements, artificial intelligence, and the modeling stuff. And I'm very much connected with all those worlds. And Jason, after this morning's session, said that the question I asked about just this topic he thought was really important. So while there are not many of you, I think this may set you up well for where you want to go off and do some, I'll call it learning, growth, and research, because while you've heard about artificial intelligence and where it's going, it is happening a little bit quicker than some of us, I think, including Jason and Tariq, even myself. It is happening. It's not going to happen everywhere. It's not going to be, like next week you walk in and the robots have replaced you. But there will be some shifts, particularly in some parts of the industry, and I think it'll grow quite a few places. So it says consultant up there. I do just a little bit of consulting. I do much more speaking and training, and really I'm semi-retired, meaning that if it's not a fun job, not a fun thing, I don't do it. Which I also speak on that because people are like, how did you get that kind of job? Well, I've also been in computers now for 40 years, programming them, messing them up, testing them. So it took me a long time to get here. There's no easy path to doing this kind of stuff. The other thing I get asked quite a bit is the name Grand Software Testing. That's my company. And really, it's just myself, and occasionally I drag my wife out because she came out of software quality assurance and configuration management. And I drag her out, make her speak about once a year, which I then pay for with vacations and whatnot. But they say, well, what's so grand about your software testing? What the heck's up with that name? Well, I actually live in Colorado, up in the mountains. The county I live in is named Grand County. And about every fifth business up there is Grand something. Grand Store, Grand Electric, Grand Plumbing. So when I was not thinking, very creatively, I said, well, maybe I should just be the one high-tech company up in this ranch land, and it is mostly ranchers. So hence the name Grand Software Testing. There's nothing grand about it. I just live in Grand County, up in the mountains. And yes, it's already snowing up there. While I was on the way here, it's been snowing at my house, which is good news because in a few weeks I turn into a ski bum. That's really what I do in my life is I'm a ski bum. But I want to talk about this issue of architectures. And Brian was kind of nice, but he's going to run out soon. But it's an area that some of us that work on looking down the road a little bit, and I also work, as Brian kind of intimated, on standards in the world. Particularly International Standards Organization, ISO, which has way too many standards, but that's another subject. But I'm the project editor for ISO 29119 software test. It's the standard that's out there in the world for software testing that ISO put out. I'm the IEEE representative project editor for what's now 5 parts, maybe soon 6. There are a lot of people that hate the thing, particularly in the US. It gets a little bit better play in Asia, some places in Europe. But it is a reference that people should at least be aware of. And it's been out for 5 years. We're starting a revision process on it right now. And so if anybody wants to be involved, come see me, send me an email. We're always looking for people actually out in the practitioner side to review the standard and help on it. And it's got some weaknesses, both in the material that's in there, some of the things like processes and techniques I was never happy with. While it's a world standard, it's also a world standard. And what I mean by that is we had to make people all across the world in the standards organizations, Europe, Asia, South America, North America, be happy with the thing. Sort of imagine the United Nations, okay? Except only about 20 people. Trying to get 20 people to agree on anything is difficult, as some of you know probably from where you work. But these were 20 people from literally all over the world trying to agree on this thing. But one of the areas that's really weak in it, and that in the next 2 years when it comes under revision, or 3 years, particularly some of us, Japan, China, I think are with me on this, is in this areas of architectures and support environments. Whether it goes anywhere, I can't tell you. So you're getting a little bit of preview for things that may be coming in standards if you ever have to work with those. I think you're getting a little bit of preview here for the kinds of things that if you're working with AI kinds of systems or IoT systems, advanced systems, I think you're going to have to be thinking about some of these things. I don't give you all the answers here. There's not a lot of charts here. I don't bombard you with, I'll say, too many charts. But there is a paper that I did at an IEEE conference exactly supporting this subject. So if you want more, I can get you the paper. Didn't put it in this conference because they didn't ask for that paper, which I don't know why nobody asked for it. And by the way, I left my clicker in the hotel room. Tomorrow I'll have my clicker back. I always forget something, but fortunately not too many charts. Internet of Things. We hear about it. It's a growth area, maybe still in its immature infancy side of growing. And I've been talking about it now and researching it for a few years. Why? Because it's one of the topics I regard as fun. It's also an outgrowth of the area that I spent most of my career in, which is embedded systems. And all of our cars now for a number of years have had processors in them. All of our planes have processors in them. Our rockets, our medical devices, the amount of software that's embedded in devices is rather long, and to the point where a lot of people aren't even aware how much software is in some of the systems, like a car, that they go around and use. And for many years, on embedded devices, there was a small little community that I was part of. And yeah, we were software and we did software testing, but it was very different from probably what a lot of you do with software on PCs or information systems or web systems and things like that. And there were things that we had to worry about that you never worry about, and vice versa. And then somewhere in the last few years, and I started probably talking about it 10, 15 years ago, people got the brilliant idea of, well, we'll take these embedded devices and we'll plug them into some kind of network and put in a Wi-Fi card or a Bluetooth card or a cellular card, and we'll plug into the web, we'll plug into the network. And I immediately started raising a lot of concern areas. And first people said, don't worry about it. These are tried and true systems. We'll just plug them in. Everything will be good. Anybody remember a few years ago where a Jeep Cherokee got hacked? Yeah. And I was actually at an embedded conference when that happened, and that immediately switched to be the big thing that we were all talking about. A few of us had things on embedded security. About 2 years before that, when I would talk about embedded security, people would go, nah, you don't need to worry about it. Nothing's ever been hacked in the embedded world. And then the Jeep got hacked. Anybody heard of Stuxnet? That's another big hack in the embedded world. Anybody remember last year Internet of Things was used to hack a bunch of websites? Anybody hear about that one? I think it was Mariah, and the story there, I've got lots of stories. And by the way, this is a talk on Internet of Things, but as far as I know, that was the first time an Internet of Things set of devices was used on a denial of service attack. It was semi-big news. I mean, it was on the national news and things like that, and some of us that dabble in this world were paying pretty close attention to it. And so if I have parts of this story wrong, this is subject to other researchers, and I only pay attention a little bit to the dark web and white hat kinds of things. But what the IoT devices that were used were various kind of things like nanny cams and all kinds of little devices that were in people's houses that are connected to the internet through IP. What the hackers did was, anybody heard of the website Shodan? You should write that down. I don't think it's on the charts anywhere here. If you go to the Shodan website, it's a website, but what it does is it lists all the IP devices that are out there, basically, that it's been able to find. And what Shodan Crawler does is it goes around and pings IP devices kind of through the IP structure. When it finds one that responds, it then queries it to see if it's like an IoT device that's using a default password. Anybody got IoT devices that you didn't change your default passwords? You know, some of you are smiling. By the way, I go around to relatives and friends' houses. First thing I do is see if I can hack their systems. And yes, I can. And then they go, should we change? And I would go, yeah, because I'm a nice guy and I'm telling you the bad guys won't do that. But so what Shodan does, and you can go on there, you can log on, you can zero down to like this area, and you can see the devices that are using default passwords. What does the default password give you? Everything administrative. I can log on to the thing, right? So what they did was the bad guys now, they used a system that went and put basically a worm, a virus, on these IoT devices. And then the next step was, after they got it deployed out to, I don't know, tens of thousands, hundreds of thousands of devices, at a set time, they had all these devices conduct a denial of service attack, which is basically just trying to log on to well-known websites like Netflix. I think Facebook was hit. I think the other one might have been Google, but there might have been another one. But 3 or 4 big websites were brought to their knees for a period of time by this denial of service attack. And if you don't know what a denial of service attack is and you're in the test industry, you should probably start learning that one, by the way. But the speculation is they really weren't trying to bring down Netflix or Facebook. It was a smokescreen. There was one little website that was also hit with a denial of service attack and took offline for a day or 2 or 3 or 4. That was owned by a gentleman that's kind of in the white hat, black hat world. He'd evidently published some things that the black hat guys did not like, and they were punishing him. And at least that's the story that's going around, is that really he was being slapped upside the head in this world of IoT. But as far as those of us that work with IoT know, in this issue of architectures and in test environments and things like that, that was like, you know, kind of a big watershed event for the IoT world. So it's hot, it's growing, they're putting these things out there, but we're doing some bad things, like that story kind of indicates. test architecture, as Brian kind of indicated, people go, there's a test architecture? You know, I've never heard of such a thing. There is, and we're going to talk about that in this presentation, why that's important. Now, most of you for architecture and things like that, it's a PC logged onto a web system or a PC running IT system or something like that, or maybe a couple of PCs. Some of you might be dealing with embedded devices that are a little bit more. But when we go into this world of IoT, I'm going to advocate here that you got to think a little bit more, especially if we put in there things like AI. So the support environments which relate to the architecture, the test support environments, something that I talk about and feel pretty passionate about. And so for me, as I said, IoT is an evolution of the embedded systems out into the rest of the world of computers. Now we have things like a user interface and connected to the internet and a bunch of things that a lot of us never had to worry about. All of a sudden we're having to worry about. But at the same time, as these devices come online, you know, everybody wants to be successful, to be a winner on these things. And that's certainly the case here. So I'm going to talk some more introduction here. I'm going to define these things a little bit, at least from my perspective. Now, as we move to the standards that I mentioned that I support and work with other industries and companies and governments, these definitions may change because we don't have a standard on them. We don't have universally accepted things on this. So I'm going to talk that. We're going to do some little thought experiments so you get a better understanding of it, maybe see what I missed and start thinking about these things on both architecture, test architecture. Then we'll do something with test environments also. And then something that some of us, including my friends in Japan, are calling test viewpoints. Want to hit that and mention some of the risk areas. Right before lunch, went to the lady that talked about risk-based testing. Yeah, that's very big for me in the world of embedded and IoT, particularly as you move into things like airplanes and medical devices. You can kill people, quite literally, in some of these things. And a lot of the IoT devices are now bordering into that medical device world. So risks become a big issue to know and understand. And I want to look at some examples of things that are already out there in this kind of IoT embedded space of larger architectures that are already in use by some of the companies and players in this world that maybe some of you aren't aware of. And they're bigger than just testing the little PC, you know, at your desk. You'll see they're very much bigger than that. I'll outline some of the future research kinds of things and mention, at least in passing, you know, where like the AI stuff is going on this. So I always like to, you know, start way back in history. Mankind's been building tools for a long time. Those are like some of our earliest tools. And we used to say, gee, what separates man, intelligent, from animals? And for a long time we said, well, man's intelligent because we use tools. Well, then we found birds use tools, and some of the apes use tools, and dolphins use tools, and dolphins have communication. And so all of a sudden, the use of physical devices and tools, that wasn't what made intelligence. But you march on in time, and these are physical systems. And we went from the Stone Age, and we went to the age of agriculture. That was 3,000, 4,000, 5,000 years ago. I hear different numbers, but that's where we first stopped being kind of hunter-gatherers, working with stones, and started planting crops and having towns and villages and cities, ultimately very large cities, very large industry. And most of us very familiar with industry. It continues growing, but now populated by robots, right? One of my favorite jokes, and I really wish I knew, I've asked several of my friends, okay, where did I hear this one? Because I don't know, I think it might have been somebody in Sweden, but they were talking, the factory of the future maybe not that distant future, has two employees, a dog and a man, and a bunch of robots. So the dog's job, the man's job is to feed the dog. The dog's job is to keep the man away from the robots. A few of you snickered about that. But that's not that far from the truth. I mean, we're going to have a very different kind of world here when we work with the robots and AI. And I think we're seeing some of that now in the world that we've now moved into, literally in my lifetime, which is the cyber systems, somewhere in the 1950s. And yes, I'm that old. And the first computers I worked on, kid you not, I had punch cards. And you know, big systems that occupied rooms about this large, very expensive, and you know, that was in the 1970s. But these systems have continued to grow to the point where I left my phone. But now everybody in the world walks around with smartphones, which are really just a very compact computer. Everywhere I go, this is the position. You know, sometimes this way. But it's the new position of mankind evidently is worshiping the great God of smartphones. So we put them in everything. Our cities, we've networked everything. We got them in all our devices out there and growing in terms of number of devices to now what we're calling cyber physical systems. Some people call it Industrial Revolution 4.0. I kind of don't like that because I really find these cyber systems, these smart systems, these AI systems really are driving us in different and unique ways that I think we're only just now getting a handle on. You kind of heard it in some of the talks on AI here, and you really have to be ready for that stuff. And you know, the number of devices we'll look at here, but the AI people, the IoT people, the embedded people, we're talking billions of these things and huge amounts of data. It's a little terrifying actually for this kind of stuff. So, you know, what are some of these things, some definitions? Well, embedded for me always was a system that was kind of running some kind of specialized hardware, cars, airplanes, medical devices, as opposed to, yes, I know your software runs on a computer somewhere, but the computers were kind of generic. They were generic platforms. The web, yeah, a bunch of web servers, specialized hardware, but it was literally tens of thousands of servers and things like that, replicated to form the cloud and things like that. The embedded systems were things that I might put in my chest and keep my heart pumping, a pacemaker. You move from that kind of embedded system to this kind of embedded system, that's an Apple Smartwatch, which is now considered in the wearable IoT realm. So they've kind of gone from embedded into the IoT world by taking what used to be watches that they were a little computer, digital watch, but not networked, to now the thing is networked and talking over here to my phone, which talks to the internet and you know, on to the rest of the world. And these things also embedded kind of included robots. Now I studied robots, but I never considered myself a robotic person. They were really specialized, and the software for them was really specialized. But they're kind of in the embedded space also, and now they've kind of merged into kind of the IoT embedded space. And at the same time, I was well aware of what was going on with the web and PCs. I've had PCs since 1979, and was on the network and on the internet in the very early days and watched the whole thing grow. And I forget when I got my first cell phone. It was one of those big brick things that could just make phone calls. And you know, then I got a flip phone, and now I've got like 3 or 4 smartphones. And by the way, I call this Wife 2.1. My phone is Wife 2.0. And I still have a Wife 1.0, but she's wife number 1. But they all help me. My wife helps me a lot. The phone helps me a lot. This thing is always telling me that I need to exercise more, breathe more. It tells me when to get up, so I'm very much used to being told what to do. And I love all of them, including particularly my wife. And I have to say that for obvious political reasons. So we have these devices with the cars. You're all aware that if your car is inside of the last 10 years old, there's brakes that are controlled by computers, and they're getting smarter and smarter, and what's called adaptive braking. And the cars are moving from what's known as a level 1 autonomous capability, which we've all had a little bit of, to level 2, 3, ultimately 5 autonomous vehicles. Means no steering wheel. Anybody worried by that? You know, and some of us, we mentioned, there's actually a simple test for this kind of AI, an embedded IoT system. If the cars, when they're autonomous level 5, if their accident rate is lower than human accident rates, which they're already getting better than that, it'll be much safer to drive in a level 4 or level 5 autonomous vehicle, because your likelihood of getting in an accident will be pretty much reduced, which humans are terrible drivers, by the way. I know all the men in the room are going, no, I'm a good driver, right? You know, according to my wife, I'm not a good driver. I live in the mountains. I have a four-wheel drive, all-wheel drive, high-speed car, and yes, I drive way too fast on snowy roads. A week ago, I hit a deer. So maybe I'm not that good a driver. But Internet of Things, you know, are now merging these things where we're now talking, our cars talk to our smartphone. You all know that your car records records of what you're doing, particularly if you get into an accident. Do you all know this? If your airbag's deployed, the insurance companies can now find out what you were doing for between 1 and 5 seconds right before you got in the accident. So if you're saying, I was only going 55 miles an hour in a 55 mile per hour zone, the system will tell them that you were doing 70. Will they cover your insurance at that point? I got a probably. Depends. If they can show, and the police can show that you were at fault, the insurance company may not pay. You know, and now, is that invasion of privacy? Got some people, no, it's not. Public record? People that don't know about it's going to say, well, I didn't know it was public record.
If you're driving along a public road, then everybody around you can see that you're passing them. The speed you're going is their record.
Yeah, okay. You know, these things are questions that I ask that we all have to think, you know, what are the answers on it? So we have these devices, and now we're going into the full-up Internet of Things. I'll start, and by the way, I'm not trying to be sexist or anything like that. This is a model in some, I don't know if it was Miss America or something like that, but the reason she's wearing is so you can actually see what she's wearing. She's got some kind of smart device on her wrist if you look closely there. And then over here, she's got a glucose monitoring. She's diabetic. And the monitor system is monitoring in real time her glucose. It will talk to her watch and sound an alarm if she's getting sick. That's kind of good, okay? That can help somebody like that. And so you wouldn't be able to see these things unless she was wearing the bathing suit. Now, a guy I've worked with, he's got one of these things, and you can never tell he's got it on. But occasionally I've been with him, and he gets a little alarm and goes, you know, hey, I got to eat a piece of sugar, or I got to take a shot because my system's getting wonky. Those are Internet of Things devices. Those are medical devices. They have to be done under FDA regulations because they are medical devices. This is an Apple Watch 1. I've had it for a few years. The new Apple Watch 3 came out. Anybody know what's unique about that? Fault detection. That's not what I'm looking for, but yeah, there's some of that. What? Bart?
EKG monitor.
Yeah, but it's FDA approved. It's cleared by the government now as a medical device, which they weren't before. This one monitors things, but it wasn't classified as a medical device. Now it is. Is that a good thing? Can be. So, another true story. Fitbit, not Apple. A guy was exercising, went into some kind of cardiac distress with his IoT device on, went to the hospital, don't know how he got in there, and the doctors said, can we take your Fitbit and download the information so we can see what's been going on for, I think it's an hour, something like that. Now that's not a medically approved device, but the doctors were willing to use it, okay, to make treatment decisions with other things. So it wasn't the only one. But it raises some interesting, for me, ethical IoT questions when we start using these devices in ways that maybe the manufacturers, would say, don't do that. This little thing here got a big kick. The guy up there, I'd used this already. Anybody look at what it says on the back? It says, do not throw at the head. I looked at that and went, I was just kind of throwing in the general direction of the person's head. But so we have these devices, okay? We have all these IoT devices. We're putting more and more of them everywhere. And they've got little disclaimers. Don't use as a medical device. Then we go and use them as a medical device. Don't throw it at the head. And so as a person, as a tester, as somebody that encourages you all to think outside of the box, I kind of have to raise the questions of, yeah, you're being told don't test that, but if it's being used that way, what obligations do we have to consider those things and to test those things? And then there's this one up here. I'm going to talk a little bit more about this at a couple points, but this is one of the modern cars. This is actually in Colorado here. If you look closely, I realize it's hard to see in that picture. That car is covered in drapes. Anybody got a clue what's going on with that car covered in drapes? They are testing it. They are testing it on a particular road that I drive on at 70 miles an hour sometimes. It's a dirt road in the middle of the mountains, and you can drive 70 miles an hour because it's in the middle of nowhere. I've never seen a sheriff there. But you can go that fast. It's a really good test track because of that. It also goes very high up. What are some other reasons we might want to test a car in Colorado? No, well, or at least the driver, unless you're wearing there's some avoidance of injury because there's nobody on this road most of the time. I count 25 miles. I'll go by usually 4 other cars coming the other direction, sometimes 5. Yeah, I'm metric crazy. What else for Colorado?
High altitude.
High altitude. What else?
Animals.
Animals. Now they haven't got to the point of crash avoidance. I would like to have seen if my car was smart enough to avoid that darn deer, because I was about 1/10 of a second too slow, as near as I can figure. I just almost didn't damage the car that much. I think the deer actually lived. A little bit of damage to the car, but near as I can figure, I was at 65, I was about 1/10 of a second slow. But would have a smart car been able to avoid that deer? I'm really curious about that one. What else? Snow. What was the other one? Bumps on the road, dirt. How about cold? Do cars perform differently in the cold? Yes, they do. And Colorado has all those things. So a few years back, again, being a tester and being an observer, we started seeing these cars. and actually I got chased away at one point because I was like trying to check it out, and a security guard came up and told me to move away, wouldn't tell me what was going on. You can't see it here in this picture, but several things are going on. One is the license plate on the car. It says manufacturer Michigan. Okay, so it's a Michigan license plate. And the other thing you don't see, my wife actually took this picture. There's a chase van right behind her, this car, that's trying to cut her off because they can see her with her camera out taking pictures. Why don't they want pictures taken? Proprietary, essentially, that's it. These are cars that haven't been released to the public or even the public magazines yet, that they're up testing. And that goes to environments. We're going to come back to that story. But, you know, and by the way, this is very nice scenery and things like that. Now, these are testers driving these things, which got to be kind of a cool job, right, as a tester. And they built this really nice test facility. For a year or so, we were driving by it going, I wonder what the heck they're building. It was just off of I-70 on US 40, nice big building. And finally, they put up a sign, high altitude cold test chamber or something like that was the, and it's a group out of Denver. And I guess they contract, obviously, with people from Michigan to test things. And no, you really can't see what the manufacturer of the car is, other than it's a truck or a sedan or an SUV kind of thing. But I see them all the time driving around. Occasionally I see them on this road broke down. I'll come by and they'll have the chase vehicle there and a mechanic out trying to fix the thing. And so I guess, is that a test that worked? You know, I always like tests that broke things. So I guess that was a test that worked for them. So some definitions here. These are the definitions I'm leaning towards here. Software test architecture. And this is different from the architecture of the system, okay? Because you have the architecture of the system. This is my definition of software test architecture. The processes, plural, and the products of planning, designing, and constructing test cases done for supporting the test structure. So the whole thing. In the case of that car system, it's the building with all their test equipment in it, it's the chase vehicle, it's the car itself, and it's the road that they were driving up, and the circuit, and it's the circuit they can drive on. It's about a 150-mile circuit that they can drive. And so, you know, we include in that things like the tools. And I suspect the cars that they're driving, at least the world I came out of, aircraft, spacecraft, rockets, we had special test configurations that we put special test instrumentation in the system or the vehicle so we could plug in on that version and get extra information that you wouldn't normally have. But the modern cars now actually have those plugs, and some of them actually have onboard self-diagnostics that they're starting to give more and more information on. So I include things like the environment, the documentation, tooling, viewpoints, analytics. Now, I'm not going to talk a lot of analytics in this talk. I do that in others. I think more tomorrow. But so when I talk about this test architecture, this is the kind of thing that I think, particularly as we move into the more advanced world of like AI and IoT, that testers or somebody under the guise of being a tester is going to have to sit and think about and design. And the reason I say that is the world I came out of, this was one of my jobs in the embedded systems of rockets and spacecraft. This is what I did. And it isn't just getting the PC and plugging it in and hooking it into the internet in this case. The computing environment to support the test, the overall structures within which a user, computer, and program operates. So for IoT devices, it's going to include the IoT device, probably a network connection, possibly if you're talking to, say, a smartphone, it'd have to include the smartphone. So now I'm up to 3 or 4 devices. It might include a router. It might include going out to the cloud if you're talking a connection to the cloud. And all of that I would have to architect and figure out how to get that set up. I run into some test teams that go, well, I'm just testing the watch. Do I need to test these other things? My answer is yes. I get arguments of no, I'm just going to test. This would be what's called the edge device, by the way. I think that's a limitation on the testing. More on that coming up. Viewpoint. This comes from my Japanese friends. That term may change. I kind of like the name Viewpoint, though. But the viewpoint is the system engineering viewpoint that's partitioning or restricting concerns of the system. Again, I'm going to give you examples of that. We'll do some exercises with that. And then there's the viewpoint, and then there's the software user, and they're kind of closely related to each other, but slightly different. But typically, the software and humans are only part of the users of the system. The other big one that people forget is that unique hardware. The hardware, the interfaces, maybe the smartphone, even the cloud, to me, those are all users of the IoT device or the embedded device. And I realize a lot of people could argue with that, and this isn't a 100% guaranteed definition. But when I talk software users, I am not just thinking human anymore. I'm thinking a much larger global picture on things. And I have to do that because the world I came out of, that's how I had to test the systems I worked on. It wasn't just humans, it was engines, it was controllers, it was actuators, it was sensors, and that. Anybody familiar with James Whittaker's work? If you're not familiar with James Whittaker, first off, really good speaker. He's kind of moved out of the software testing world and now does, I'll call it motivational speaking of IT in general. Really good speaker, pretty good friend. A few years ago, nowadays it's AI scaring you all. About, I think 4 years ago, maybe 5, he went to a series of test conferences and he said, testing is dead. Anybody hear that one? And people were freaking out. I mean, just freaking out. And what he was really talking about is manual testing is dead. And you hear that a little bit with the AI stuff. The manual testing that you're all maybe still doing, that's going to slowly, not everywhere, but that's slowly going to fade away and be taken over by AI and robots and things like that. And he wrote a series of books on breaking software, breaking web software, breaking software security. And I talked with him, and the book I wrote was on breaking mobile and embedded devices. And now I'm kind of working on a second book on breaking IoT devices. But the concept that he worked on was that we have to not just test the requirements and do the positive kind of testing that you're probably all real familiar with, what some people call the checking verification tests. He very much advocates trying to stress the software. I think Tariq used that term this morning, and trying to break the software. And that's really the world I came out of too. Yes, we tested requirements, but that was, and actually ran some studies on this, that was only about 40% of the job. I looked at our system level tests, about 40% of them were testing requirements, meaning about 60% never really touched any of the formal requirements. They were trying to do this breaking stuff. And he listed 4 fundamental capabilities that all software has, including embedded in IoT, by the way. And he said software accepts inputs from the environment. There's that word environment get. Software produces outputs and transmit it back to the environment. So input, output, no big surprise there. Software stores data internally to the software in memory and does computations and also stores that in memory. So you got things going on inside of the computer itself. And then software performs some kind of computation based upon the inputs, storing the data and producing it out. And that's true. Those are the 4. Embedded does that, PC does that, web does that. Pretty much you name a piece of software, it's got those capabilities in it. In talks with him, I went, well, but the embedded world and then the smartphone world and now the IoT world, it's got some subtle variations of that. The big one that I always dealt with was performance within time. of some kind of complex communication. The systems I worked on and some medical devices that I'm familiar with, their computation cycle, how fast they cycle from input, process, and output, the ones I worked on was 10 milliseconds. So every 10 milliseconds we had to have new input and produce new output inside of the processor. Testing that meant that no human could respond that quick. So we had to do automation. We had to have automated inputs ready every 10 milliseconds, process, record the outputs after that 10 millisecond processing. We then had really 10 milliseconds to figure out new inputs going back into the system. It was a challenge. So performance and very complex computations going on there. Testing with specialized hardware. Airplanes, very specialized. I've been into Boeing and Airbus and places like that. I've talked at conferences and had people from Daimler and places like that and talked with them. Cars, specialized hardware. Airplanes, specialized hardware. Medical devices, specialized hardware. PCs, yes, they're hardware, but it's very generic. Then we were very worried about verifying and validating qualities. Things like safety, security, I mentioned privacy already, reliability, and a whole list that ISO has of qualities that were of concern to me as a tester, and things that were sometimes hard to get at, like performance at a 10 millisecond level. How do I measure those kinds of things? And then testing in kind of this holistic architecture and environment. And so early on, I just learned how to do this stuff. And then as I started teaching, I realized, gee, I've done something that not everybody does, thinking about this architecture of these systems, of the test devices, the hardware, the software, the automation tools. And so I started realizing places I worked, we did very early testing on prototypes. We were very holistic, and what I mean by that is I didn't just think about the software, I had to think about the hardware, I had to think about the system, I had to think about the operations going on, I had to take a very large picture of things. Rapid testing, 10 milliseconds is pretty rapid, and then testing off into the field. I kind of mentioned that with the car. The car is driving around in the mountains of Colorado, and they're testing it because that's a realistic, very hard environment. They test in other places too. They test in cities, and they test in, I'll call it the suburbs. And we're seeing that with the self-driving vehicles, right? Right at the moment, we saw some of the videos, they just kind of, those are great videos, by the way. They kind of drove around in the parks of Google and things like that and ran over things, and everybody was told stay away, and then they got better, and then they graduated out into driving around the cities. Now Colorado, nothing against this part of the country, because I know you all love your beer here too, but Colorado loves their beer too. Any guesses what our first self-driving vehicle was in Colorado? A beer truck. I kid you not, a beer truck went from northern Colorado down to southern Colorado. I don't know why they picked a beer truck, but it kind of seemed apropos for Colorado. But that's field testing, and we're seeing more and more of that kind of field testing out there. Pardon me? No, I think actually it might have been Budweiser. I'm not sure. Again, a lot of these things, when they test those things, they put the trucks and things in drapes so that, or in the cars, so that if something bad happens, nobody goes, oh, Ford did it again, because they get a little bit of that, Uber crashed and killed somebody, and they were all over the news, and I'm sure Uber was like, we should have had our car in drapes, because nobody likes bad press when a test goes bad. And so I've been talking about this IoT stuff and this architecture stuff and analytics and a little bit of the AI stuff for a while. So last year at a conference, I presented on some things. And then this year at the same conference, I refined things. And then I'm kind of talking about that here. And I said to the participants, and these were academic research types, I go, we don't have definitions of these things. And I was expecting somebody to get up and go, yes, we do. And they didn't. And I was like, oh, well, yet again, I'm poking at something that, I've got this, well, we don't know, but you're asking the right question. You run with it and you figure out the answers. So that's this year's presentation. And there were no standards. As I said, I work on standards. It's been one of my jobs now for IEEE and ISO. And so I know the standards don't address it. The academics said, have a nice time addressing that stuff. And so last year and now into this year, I've been looking for examples. That's kind of what's in this presentation. I want to give you some examples. Got some mind maps coming up here. And the IoT is maturing from chaos total to just minor chaos, I guess is the way I kind of see it. And so you have this thing going on where IoT is kind of like everywhere. And the IoT people are doing things like deploying them. Before, I think we've really thought it out, that we did this in Denver also. One of the little small suburbs had this great idea to improve traffic. And they put up traffic IoT cams at all the red light intersections. People freaked out. They were like, it's red light cameras, you're going to send us all tickets. And the traffic engineers were like, no, we're just trying to make it so you're not sitting at that stupid stoplight for 5 minutes while it's red when there's nobody else coming the other way, because traffic would flow much better. I've done that. I don't like sitting there seeing nobody's coming. The light should be smart enough to decide, turn green, let me through. And that's really what they were headed toward. But people thought it was being used for something much more nefarious. So it created chaos. It was on the news. And I haven't heard anything since then on it, so it must have been happier. So this notion of architecture, a test architecture, what things in IoT and embedded and these newer systems do I have to think about? I have to think about the hardware, okay? I have to think about possible users. I have to think about billions of devices, maybe. Or in the case of like those red light cameras, that little suburb, I think they said they had like 100 different stoplights. So when they're testing that, do they test the individual red light camera and not with all 100 devices in there? I think they kind of have to test all 100. They have to test the individual device, then they have to test all 100, then they have to test it inside of their scheme of using that data. I think they're still working on that, by the way. But we're going to have to test lots of these combinations of devices. Software and everything, and then this notion of emerging use of AI that you've heard about yesterday and today in analytics. Anybody doing anything with analytics? Besides the ones that I've mentioned and Tariq and Jason mentioned, you want a good career option, go into analysis and data analytics. You'll have lots of career opportunities. And whoever this morning said they were a mathematician, yeah, I was a mathematician once upon a time too. So I kind of like analytics, but the class I disliked the most was statistics, and now I've been doing statistics for a lot of years, which is ironic, I guess. I didn't like it, but I ended up doing it anyways. But AI and analytics is part of this whole architecture issue that we as testers are going to have to wrestle with. But then the bottom one there, it's not really new, but it's important. You're also going to have to figure out how to do this with inside a cost and schedule, right? It isn't, the kind of thing where you can have 100 IoT devices, all plugged into a lab somewhere. We're going to have to do like field stuff. We're still going to have cost and schedule restrictions. And I've forgotten your name. Jeremy. Yeah.
So I noticed you don't have life cycle up here. But,
No, I don't.
So one of the things I know the healthcare industry, so it's like embedded devices, like for like literally embedded in your skin. If you have, say, a specter like attack that's discovered, one of the things that they've discovered is that, well, in order to patch it from a software perspective, it takes more CPU cycles. So instead of physically having to open people up and pull the device out and replace it, they're starting to actually think about, like, this thing is gonna last 10 years, so we're only gonna be able to use one of the 2 cores, and we'll turn on the second core.
Later on.
When we have to. And I don't see any of that.
I've thought about that. That might be a good addition. We've got a little exercise coming up. We should suggest that because I like that one. I may have something on that. And what he's talking about, actually, we were kind of talking about this at lunch. There was a lady there, kind of out of the medical industry. A friend of mine had a pacemaker. It was recalled. He went into the doctor and they updated the software in his chest. I'd have died before I got to the doctor. You know, just the idea that my pacemaker software was under recall and I had to go in to have it, you know, updated in real time while it was still in my chest. That's kind of, it terrifies me. It just, you know, but yeah, oh, well, we're running out of CPU cycles. We're going to turn on the other processor. That's even more scary in some ways, right? Because now we're kind of changing the hardware and the software, you know.
The other scary part of that scenario is that normally when you update the software, you reboot the system.
Yes.
Pacemaker, you can't reboot it while you're updating.
Well, they may. They may. Because he's in the doctor's office. They may have a, you know, reboot. And the doctor's right there with the external panels.
Right.
You know, oh, he's going into fibrillation.
But that's a good service.
Well, I'm just sure that's why they said they didn't upload, say, put your phone up to your chest, we're going to upload it right now.
Yeah, but that to me sounds like a uniquely IoT concern. Because the device is still in operation.
It is uniquely, right, and that's some of the IoT stuff that, you know, we in this architecture issue and testing thing, I think we have to think about. You got it, you're right on that. But, so I started thinking about this stuff. And anybody use mind maps? It's a really great technique. If you don't use it, you should. You should go find out about them. This is actually a mind map tool. There's a lot of free ones. It's a really cool way to like capture information. And so I'm going to show you a series of the mind maps, and we're going to use these in some exercises here. So I started out with this notion of IoT test architecture. And it's not the architecture of the device, it's the architecture of my test system. Again, I'm trying to emphasize that. And so I have viewpoints, I have tooling, I have products, support processes, and environments. Do I have life cycle up there anywhere? So Jeremy, you're right. Probably life cycle should show up in here, maybe somewhere. So that first level of nodes is what you're seeing up there on things. And then I decompose from there further. And so I went from products, I said, well, there's hardware, that's a product. Software is a product. The system itself is a product because that's the combination of the hardware and software together, and I have to think the system side. But the funny one is documentation. Do I have to test documentation? I got some people saying yes. And you know, one of the big concerns we have in cars actually right at the moment is and I just heard this being talked about by some car manufacturers. They're struggling with how to have like an online in-car help feature that explains how to use all the things that the cars can now do, because they're finding half or maybe a little bit less of the people have no clue how to run their new cars, basically. So they don't use all the things the cars can do because they can't get by that welcome to Ford screen. And they can't turn their radio on, they can't turn their air conditioning on, and they're just kind of freaked out by it. And it's like, how do you have like online documentation? So, and so documentation including test, user information, management documentation, analytics. And then you get down to here, and we're going to work on this. You see the little nodes that come out that have nothing. That's where I stopped my analysis, but I want to go with you guys and fill out some of those things here in a few minutes. Support processes, that's probably where we'd put life cycle in there, Jeremy. I think you're right. You'll see there's one line with nothing on it, because I was like, I bet there's something I've totally forgotten here, which is why I like this as an exercise. And then environments, I can have a dev environment, development environment. Places I worked, we had separate little processors that we could do unit level white box testing on these little chips that we could load the software, little pieces of it, and they could run on the actual processor. Wasn't with inside of the whole system, but they could see what was going on at a very low level. That was a dev environment. We also had simulators. We also had emulators, but we didn't fully trust simulators and emulators. We were very conservative in the rocket world. We wanted on the real hardware as soon as possible. Then we went into the area I ran on the real hardware, and then as much of the hardware as we could figure out, except we didn't have rocket engines because that made all my testers nervous. And when we did have things that would blow up. That made them nervous also. Then we had the test environment. That was the labs that I helped set up and run, and very expensive, millions of dollars. Then you have the real world. That's the Ford cars or GM or whoever it is driving around in the mountains of Colorado, or the streets here in town, you know, testing self-driving vehicles. That's the real world. Tooling probably should be a lot there. We'll talk about that in a moment. Viewpoints. The viewpoint, to understand it, these are examples of viewpoints. I'll do the ones at the bottom first. You have the developer, the dev view of the system. You have the tester's view. Those are probably two different viewpoints in my experience. Management's probably a third different view. If you've got an ops or operations element, that's another one. And then you have the stakeholders. And then you see a blank line. So those are certainly different viewpoints that I as a tester have to think about when I'm setting my test architectures up in my test environments and running my tests, because I've had different questions from all of those entities. You know, why aren't you testing this? Why are you testing this? And then users. I mentioned that I don't see just human users a bit ago. So I started enumerating my users. Hardware I view as a user. Question, go.
So what about like a customer service arm of your company? Would they fall under Viewpoint because they need to deal with the user?
Yes, they would. And that's what we'll do is a little bit of exercise is that you're doing the right thing. This is really what I wanted you all to start doing is yeah, customer service, I might put that down under a branch coming out of ops because it's an operations kind of thing. So this mind map is not done, okay? I'm just showing you the concepts. So to actually use it for your own systems and things, I think you would take this, prune some things off, and add something like that in there that you're doing exactly what I wanted. So on the users, there's hardware, software, communications I view as a user. So if I'm talking out to like a Bluetooth connection or a Wi-Fi connection or a cellular connection, that's to me a user. Because like going out through a cellular provider, are all cellular providers the same? No, they're not. And very, very different. And of course, going out to the system itself. And when I say system here, think back to that traffic light system I was talking about. You have the individual little traffic light sensors. They're talking out to a communication, probably cellular system, that's talking back to a central controller somewhere at the city. But does it stop there? Might not the manufacturer of those traffic lights be interested? So the city may be talking off to the cloud somewhere where the manufacturer is getting things. So when I talk about system, I'm talking about that whole big thing, including the cloud. Now, I get pushback because a lot of people go, no, it's just my job to test that stoplight camera. Maybe, okay? But it's also our responsibility as testers. I'm an information provider. I have to provide back to the city or to the management a thing that says, okay, somebody else has to own that big cloud out there. By the way, we don't know who owns the cloud. You know, and that's a little bit scary to me because someday something's going to go wrong and people are going to go, Jeremy, it was your fault. And you're going to go, you know, again. You know, so, and so humans can be, by the way, different also. You have first-time user. That's the guy that can't figure out how to turn his Ford car information system on. A basic user, which is probably what most of us are. typical user, that's after we've done it for a while, and I'm still like learning all the features of my smartphone. I don't know about you all. And I give it to some of my little kids, and they're like, "Oh, Daddy," and it's like, how did you figure that out? It's because to them, it's not even a computer, it's just part of their extension of their arm somewhere, I think. But then you have advanced users that do things, and I've run into these people that are like, "Oh, we figured out that shortcut a long time ago." Well, really what they found is a bug that they can circumvent some part of the system, and they really use the bug to their advantage as an advanced user. And then the other one we really have to think about in this world is the bad actors, the hacker. Remember my story about the Internet of Things denial of service attack? Those were users. Those people that figured out how to do that, they were users that in our architecture we have to think about and address. So that's the kind of mind map that I started working on. And so I want to capture a couple of these things, and I'd like, and I'm sorry, I can't see your name because you're too, you said,
Melissa.
but you had, what was the one, you said, what about?
Service?
Yeah, customer service. Do you mind customer service data, by the way?
No.
Think about it. No, I'm a consultant. I do this. I've gone into places and they go, "Oh yeah, we have a lot of things coming in." Well, but it's actually a really interesting source of information because you find things that the customer service people go, "Oh yeah, we've had like hundreds of calls on this. Something's weird," and the testers go, "We never thought about that." So you can mine. This is analytics, by the way. Another one, please. Something added into the map here.
Marketing department?
Like that. Why marketing?
They also need to explain the services to users.
Well, even more important, they got to sell the thing, right? Because if they don't sell the thing, do we have jobs? Do marketing people ever say things that's not true about the thing that we're testing? I got all the time. Yeah. And now, is that good or bad? Well, it's bad in that all of a sudden you get the dev people going, "Got to put this in there, and you're going to test it tomorrow, right?" And you're like, don't know. Another one to go in here. How about coming off of basic architecture? Is there something I missed?
Obviously, life cycle, which I mentioned earlier.
I'll put that up here somewhere. And by the way, how you would do things like with mind maps in a brainstorming session, if I had it online, you'd kind of find a place to put it, and you can quickly type it in, and the system will put it in the mind map for you, and then you can decide where to put it or not put it.
Accessibility. So
Which is a quality characteristic. And so that might be under the test architecture, that missing line, that might be where I would say we should have a thing that says quality characteristics and then put what you're talking about. But yeah, I think you just found something that, I kind of missed there. So
I don't know if your intention was the way you have it, but integration, like your watch integrates to your phone.
yep.
Is that hardware or is that?
Where would it go in the picture?
Yeah, like it could go in so many different places.
Users.
Users, again, you could have that discussion back and forth. I like the integration being added in there because that's actually one in the other classes that I do that we talk a lot about in these bigger systems. Integration becomes a huge, huge issue. And so I like that you noticed I didn't put that in there. I might put it under support process, maybe tooling. I'd have to think about that. Any other obvious ones? You guys are getting the picture here, though.
Does securities fit in here anywhere?
It does under this quality one. And what was the one you told?
accessibility.
Accessibility, yes. Yeah, all the IoTs reliability, safety. There's an ISO standard, 27, I think, 100 series. There's a series of ISO quality standards, 9000 series, and quality standards that list things like security, safety, usability, accessibility, a whole series of those that, yeah, I'd kind of put somewhere up on the chart that I think we missed. Any other obvious ones?
So where does like the use cases themselves belong in that? Like what the purpose of the product is?
Where do the requirements come in?
Right. Requirements, use cases, design. Those are, to me, be branches out under support processes and development, or maybe under products. Again, there's no one right way to draw these things, but I think most of you have the idea, one, of thinking these architectural things, and then saying, where do they go in the mind map, two, and then how does it affect the overall test architecture that I'm doing? Because if I had something like an agile life cycle, is that going to affect my test architecture? I think it might. It might affect that I have to come up with my architecture early and then let it evolve and change over time and get added to. And so some of the things you mentioned, yeah, I think I'd put, again, this wasn't intended to be a perfect answer, but mostly get you thinking about these things.
UX design?
User interface, yeah, and I might put that as a, under accessibility, right? I mean, so you can branch these things out, you can add things, you can move them around, but I think you guys are kind of getting the idea of both what I'm talking about here in terms of a test architecture, and then using a mind map to figure this out, because I did things like this when I was first on proposals as the sole tester, test manager, but we had to come up with a test architecture, which included things like tools and hardware and literally millions of dollars of stuff. And I did something, now that was long ago that I wasn't familiar with mind mapping. I did things on a whiteboard with lots of lines on stuff.
So I'm curious, would you have testing, like the kinds of tests, I want to do this kind of automated test, or is that to inform, like you take this to inform what testing?
I think it's the latter.
Okay.
And you'll see, I think some of those things that you're talking about coming up here also in a moment, because there's levels down below that. So as I said, the model's not complete. Many areas under tooling. So, am I using AI tooling? Am I using requirement management tools and compliance? So the thing was largely to get other people thinking about it, which it has at conferences and here. But the scary thing for me is all this IoT and embedded stuff. We're out fielding these things and building these things and deploying them, and a lot of us as testers are still trying to figure out how to test the things. So, there's kind of a little bit of cart before the horse here in some ways that just kind of scares me. I think we as testers and at conferences and with AI, we're going to have to catch up on these things. Hence why I kind of talk about it. So, next one. Test environments, which was one of the big things there in the picture that I started realizing both for IoT and AI and these things, we're going to have to think about these test environments to make sure we address these kinds of things. And so it's an architectural component for me, very important. A lot of us tend to think just what we're used to doing, which is, the PC sitting on the desk tied to the internet so we can load our web software on there, or our PC software or IT software. But the world that I came out of, it's a much bigger space, much bigger problem, which is what we just were looking at there. And so these function in the bigger. And so I've been talking about this test system that was in Colorado. This is actually part of the road. This is my car. This is winter. I'm driving down the road. It's a nice straight road right in here. And yeah, on that nice, both icy and snowy road, you can go way too fast. My wife won't let me do it if she's in the car. But it's straight. There's nobody else there. And somebody pointed out, you know, there's probably nothing else there to hit, maybe except some fence posts and maybe a light post. And by the way, the snowbanks, when you hit them, they're really nice at slowing you down. You slow down really quick. And you go, well, that's good, doesn't hurt the car. That's true. But you have to get towed out. And in Grand County, the tow trucks will come, and while they're coming, they call the sheriff, who will also show up, even though you didn't call him. The sheriff will give you a ticket, and then the tow company will pull you out for $300 plus whatever travel. I don't have personal experience on this directly, but I know that's what they do. So while you wouldn't necessarily get hurt, it might cost you some points on your license and a bill to the tow truck driver. So, but that's a test environment right there. That is a test environment, and yes, it was cold. So, a mind map of test environments here. And again, maybe think about this a little bit, but I said, okay, there's different kinds of classifications of these embedded IoT devices. There's what's known up here as the industrial sector. This is things like in factories and businesses and those kinds of things. And we'll talk about lower levels of that. You have the consumer side, where it's personal, consumer side. That's my watch here. Smart homes. Anybody got things in their smart homes? Alexis or any of those kinds of things? And I build a house. It's semi-smart. We're adding more smartness as I speak. And I kind of put medical, at least on like a medical device like this, on kind of the personal side. Then you have what I kind of call the middle sector, and this seems to be the bigger one, and it's kind of a combination of the industrial and consumer. So you have things like the transportation systems, large personal vehicles, industrial vehicles, IT and commercial systems, public enterprise and government, security and public safety systems. Traffic lights probably fit into that one, and you'll see there should be subs under that. Retail, store, traditional, online stores, hospitality, hybrid specializations. It's kind of cool now. A lot of them, I can order the things on my phone and I just pull up to the store and they hand me my groceries, kind of thing, which I think can be nice if I'm ordering standard things. And then healthcare and science networks, and there's a bunch of stuff under that. On the industrial side, I didn't go that level, but you have construction, commercial systems that are large, industrial, might be factories or big buildings like this, and then you have the government. Some of the industrial side are where we're actually seeing some of the early adopters between governments and industry and things like that. They're going for this stuff big time. Factory production systems, resource automation, robotics, inventory management, internal transportation, waste management, and management. And then the other big one is energy. You see some crazy things in some of these environments. Anybody hear of the Target stores getting hacked, about 2 years ago? A bunch of credit cards were stolen. Anybody know how they got into Target?
AC, the HVAC.
Yeah, the HVAC system. Jeremy has heard the story. They went in through the industrial side to get to the point of sale system, and the hackers were really smart about it because they got into the point of sale system. They installed essentially a virus, a little piece of software that would record the transactions, the credit card information, but it didn't mail it out all at once. It didn't send it out. It sent it out in little blurbs over a month or 2 or 3. I don't know how long before they found it. And that's because the Target security people were looking for like a big download. So little blurbs, that was normal kind of traffic. They just thought it was the heating and ventilation system calling home to say everything's good. What it was all your credit card information. So we have these environments, we can have these security things. So, you know, what are some other environments that aren't on my list? Anybody think of some?
Supply chain logistics.
Supply chain?
Yeah, tracking of packages.
Yep. What else? How about in the energy sector?
I don't know, something to control your hydroelectric dam?
Yeah. Dams.
Smart meters.
Smart meters. There you go. I like that one. I've had a lot of students, particularly out of the European, on smart meters. I have a smart meter. I have a smart house. I have solar panels. I don't trust the smart meter that much. Well, actually, my wife doesn't. So she's monitoring what the utility company says we're generating with what we're actually generating, and because she doesn't trust them. Something else in all that? There's bunches of those out there.
Enriching uranium,
But you're thinking Iran, aren't you? Yeah. Now, I can't spell fuge. Do y'all know what he's talking about, by the way? The centrifuges. I mentioned Stuxnet. Stuxnet, world's first weaponized virus, as far as we know, which was a little bit of letting the genie out of the box for a lot of us. It was a little bit scary, but what we don't know 100% sure, but it's pretty sure it was this country and maybe Israel. But it was a very sophisticated virus because it spread through PCs, but it wasn't infecting it was infecting the PCs, but it wasn't targeted at the PCs. It was targeted at specific, and I just forgot the names, SCADA devices, which are controllers mostly built by Siemens Corporation. These are very specialized embedded devices. And so it kept going around till somehow or another it got on to the systems that were in use in Iran. And it wiped out their centrifuges for a while. You can argue good or bad, but the bad side is now the code has been out. There's been at least 3 or 4 variants of Stuxnet, Dooku, and Son of Dooku, and we don't know what else. But the problem is these devices that they were targeting, they're everywhere. Literally, your power, your plumbing, you name it, these devices are controlling our lives, and now they're kind of vulnerable. What else? Sensor networks. I'm assuming you mean smart sensors, kind of thing. Well, they got to have some kind of smarts to be talking or somewhere.
Build them into the bridge to measure it over its lifetime.
Yep, that could be. Colorado's looking at smart roads. What would we be wanting to sense in Colorado?
Perhaps wear and tear.
Well, wear and tear, but the other big one is when does the road freeze? Because when the road freezes or is about to freeze, they want to send out the trucks to start plowing. My neighborhood has one major road in it. We have more plow trucks than they probably have in, all of Portland here. Maybe Portland has a few more, but we have a lot of trucks. Why? Because we get literally feet of snow in a year, and people want to move around. What else in IoT environments or embedded environments? Stoplights. I'll call that control systems. Okay, so again, if you were to use this kind of stuff, this is what you'd have to do. You'd have to look, okay, what's our system doing? What environments can it be deployed in? And do this kind of thing. But then you have to think, is this a medical device? Well, the answer is it's starting to be used as one. So the environment that you're thinking today may not be the environment of tomorrow. And I think, again, as testers and providers of information, we kind of have to tell our customers, our stakeholders, our managers, here's the environment we tested in. You go outside of that environment, your bets may be off. I don't know if it's still out there. There was the gentleman that had the hardware for floating point overflow. Right, on the missile. I talked to him about it. I knew quite a bit about that story for a variety of reasons. But part of that story was they started using the missile in a way the missile was not originally required or designed to do. And that was because the system had been working great. Why don't we just set it up and leave it on? Big problem. Because it wasn't designed to do that. We'd never tested it that way on that kind of thing. So environmental considerations, that's what you got to look for, those kind of things. There's a lot of debate over this stuff. And we move into the AI world, there's even more debate. So we have to understand these environments. We've got to put limitations on them. We've got to say what we tested, what we didn't test. And then we have these notions of viewpoints coming up here. Just did that exercise. So what do I mean by viewpoints? Well, viewpoints, the problem multiplies. So what I did was one little small case of a viewpoint here. Connected automobiles, because we've been kind of talking about that. So we have the viewpoint of user, non-human. Coming down, then we have the viewpoint of human, viewpoint of dev, viewpoint of tester, manager, operations, stakeholder. So those are individual viewpoints coming down there. I did this on a spreadsheet as opposed to a mind map. And by the way, this thing would go on and on down below in a spreadsheet kind of fashion. And then I said, okay, what are the sub-targets? Kind of reading off of that mind map. Hardware, software, communications, humans, first-time driver, basic driver. So did you see where those things came from? They came from back over here somewhere. Oh, where did I put it? It's somewhere in there. Yeah, I thought it was there. I'm not seeing it right away. Anyway, so you have these sub-targets. And then what I started doing is I started going down to, okay, what are specific examples of these things? So you have something like the hardware, you have the controllers, you have the sensors, you have motors, you have batteries. By the way, in IoT and mobile, batteries are a big issue, and the list would go on. And you come down to something like tester. The tester would want to think processes, planning, design techniques, maybe AI, moving into standards like ISO, and I didn't put my standard up there, but you might have to think standards. Now, not everybody wants to work with standards, I know, but some of us end up doing that just because of the environments we work in. And so this notion of viewpoints, again, is probably the least well-defined at the moment. It's not in the standards anywhere, but my friends in Japan and maybe China, we're starting to say, okay, we need to have these classifications of architecture, classifications of environments. We get down to these viewpoints, and then this is the kind of stuff I'd address in a test plan. That's where I would take this stuff is into a test plan, so that I would have these things addressed in a test plan kind of situation. So what I'm looking for, here's the environment. I'm looking to go after faults and things like that. The things that we were kind of talking about, security, reliability, and performance. And I'd want to start considering from these things like the car crash that happened in with one of the Teslas. There were several, by the way. But the story I got on that one is it was reading signs on the road. It evidently read a sign that it was like the 105, I guess, in Los Angeles, and read that as a speed indicator. Not what you want, by the way, because the car will do 105, but probably not what you want and that kind of thing. So my smartwatch here, what might be some of the viewpoints? One last little exercise on my smartwatch. Me? Yeah. What else? How about what? Services. Yeah. How about my other part of my wife over here? Where's my wife? I can't find my wife. Oh, there she is. Is this a user?
Yes.
It's connected to it. Okay. Is it connected to anything else? Potentially, the rest of the world. Monitors, I could go down into the side of my body, right? On things like that. You know, heartbeats, breath, things like that could all be users. Do I move things off from this into the cloud? Well, the answer is I don't, but I could. Or should it ask me if I want it to move to the cloud? You know, and this gets us as testers into an interesting area. A lot of these things, I personally believe the system should ask, do you want it to go to the cloud? I should have the option of saying yes or no. It's sort of like with the default passwords. Actually, the system should enforce not using a default password, you know, because of the bad users out there, the hackers, on that kind of stuff. You go from there to risks. And there's been a couple presentations here in this conference on risks. ISO 29119 is a big risk-based standard. And I've always worked with risks and tested with risks. I think it's very necessary. So in the IoT thing, as I went down these levels from viewpoints down in, then I started thinking of generalized risk areas. I'm not going to read all these. I don't read all my charts all the time. But these are the kind of risks that I would tailor down into the specific system that I'm testing and analyzing of an IoT device or embedded device, those kinds of things. And I asked the lady this morning, and I just forgot her name. I said, you know, do you have a personal set of risks and then a kind of a project set of risks? And she said, no, it's always just project. The places I worked, I had both. And what I mean by that is I had things that I didn't have enough information to justify to management and the other stakeholders that were real true risks, but they were concerns of mine. And until I got more data from doing risk-based testing and things like that, I couldn't go to management and go, this is a project level risk. And in fact, sometimes my items bubbled up and became project level risks after I did my testing and analysis of things on that. Really? Cool. I was stalling, but almost over. So from there, I go down to examples of complex systems and how they're tested. These are things that I've actually run into, by the way, embedded labs in aerospace. Airbus in Toulouse, France, has an airplane, whole airplane, that they test on. The auto industry I talked about quite a bit. Testbed cities. There's several cities around the world that want to be IoT smart city testbeds. Anybody heard of chaos engineering? If you haven't, something to research, but I think it's kind of cool. It's how we would test in these big complex environments, embedded in many, many devices out there. And these are the kind of systems that I've been talking about, that we would have lots of components and things like that going on in there. And here's a picture of some of these labs, by the way. This is an actual test lab. Won't name where, but it's a test lab. We have the computers, we have the cars, and so we have these environments that are all out there supporting the testing. I sometimes get asked, okay, you know, how does this stuff, where do we spend our effort in testing IoT? Notionally, this is where I think development spends 30 to 70% of their time on the hardware, building the sensors, devices, the code for that, and the object code. They then glue a lot of this stuff together, and then they spend some integration time up there in the real world. As testers, I think we have to test all those levels. We've got to test the low level, we've got to test the intermediate levels, and maybe way up there at the top level, we have to allocate a lot of testing to the system level testing, out driving around the roads in the car or whatever. A lot of effort has to go into that. A little nod here to the world of AI and analytics and the stuff that Tariq talked about down here. And this is the kind of stuff I've been working on the side. Real interested in working with Tariq on some things of how do we use this in the test world out there. They talked about this a little bit. This is my version from a Sweden conference. You have your training sets of data on this stuff. You have a model that you create inside of the AI system. The AI system does this for you, basically. But we then need to start testing it. And then the one Tariq poked at a little bit, if we were testing this way, I think we have to continuously have a test presence as the AI system runs. So we're kind of testing the AI system as it learns. Don't know how to do that yet, but it seems like something people in the academic world is talking about. And this is things from a Sweden conference this year, and we were like, the model verification, the AI model itself is going to constantly go under verification and validation. So future work, it just kind of was hitting on that stuff now. Self-healing systems, Tariq talked about that. National test beds, state test beds, city test beds. I'm a big believer in model-based testing is going to fit in here somehow or another. Predictive maintenance, distributed testing, working with the government and industry, because past testing like the stoplights in the whole city, that's obviously government kind of stuff. Support tools and deep learning and AI. And by the way, the standards communities are just starting to work on this stuff. We're not all the way there yet. So I spent some time on the upfront stuff, a little bit less on the later stuff. When I talked to the academics, and Tariq did those charts in opposite order. But I wanted to give you all a feel, and I know I overran, but I was having too much fun. But think on these systems, on architectures, and think of environments and testing these things. It's going to be big problems for us in this world, I believe. And it's also kind of cool stuff to think about. And with that, I'm done. These charts are out there somewhere on the web. And if you work in some of these areas, always feel free to drop me a note, because I'm curious to see how people actually do this stuff. Thanks.